So welcome everybody. My name is Antonia Jetter. I'm the chair of this doctoral committee. It is my great pleasure to introduce Ahmed Alibaj, who will be defending his dissertation today. And given that we are on Zoom, it's probably easiest if Ahmed introduces his committee members. And so the way this works is that he will be giving a presentation of about 35 minutes length. After this, we will open this up for questions from the committee to Ahmed and from the general audience to Ahmed. And then after this, the committee will meet in a breakout room and discuss what Ahmed has presented. And so without further ado, Ahmed, please present your work.
Okay, thank you so much, Professor. Thank you very much for everyone attending this presentation for my doctoral dissertation entitled Achieving Higher Reliability Organization Using Fuzzy Cognitive Maps, the Case of the Offshore Oil and Gas. Before I start my presentation, I would like to introduce my committee chair and member, Dr. Antonia Jetter, my advisor and committee chair from the ETM department, Portland State University, Dr. Wayne Wakeland as a graduate school representative from the System Science, Portland State University, Dr. Charles Weber from the ETM department, Portland State University, and Dr. Stephen Skyfers from the Department of Marine and Environmental Science from Northeastern University. So to start with this presentation, I would like to talk about the motivation of my dissertation for this research, which is the persistently high accident rate in the offshore oil and gas industry. Working on an oil rig considered that among the most dangerous jobs in the United States, and that caused accident with large number of disabilities and fatalities. Such accident can have large-scale consequences, such as the British Petroleum Deepwater Horizon in 2010, which reduced the British petroleum taxable income by more than 65 billion US dollar. This is really a very strong incentive for industry to improve its safety, but current efforts do not really yield or produce good result for many reasons. Such as the offshore operation are very complex technical system with many players, such as different highly specialized and companies and professions. The operation takes place in a very trying and hard environmental conditions. There is a really unique and specific safety culture for this industry, and safety efforts have historically focused on accident prevention and reporting, and there is still a limited knowledge about how to improve safety on system model through safety culture. So as a matter of a solution, there is a general agreement about the solution to this problem. Offshore oil and gas industry should learn from other industries with much better safety record. And also share knowledge among themselves, such as the nuclear power and airline industries. This quote from National Academies, their report on 2016 to strengthen safety culture in this particular industry, illustrate this. The knowledge transfer is supposed to occur from particular type of organization, namely the so-called high reliability organizations, HROs, and I will mention these organizations throughout the talk of this presentation. So, the objective of my dissertation to contribute to this required knowledge transfer as a long-term to help offshore oil and gas industry improve its safety based on novel planning, decision support, and training tool. And here, as a matter of scope of this dissertation, is to create a system model of the principle of HRO, represented as a fuzzy cognitive map, FCM, and that is contextualized to the specific operational and organizational setting of the offshore oil and gas industry, and that can be used to simulate the impact of planet safety interventions. So through this presentation, I want to report on my progress to achieving these objectives with the following agenda. I will first talk about the foundation for my work, namely the higher reliability organization, what are they, and how about their successful practices, and I will then discuss how modeling can help transfer knowledge from HRO to other companies, particularly in this case the offshore oil and gas, and I will outline my research question. Then I will organize the talk around 4 central activities that are part of my approach, which I namely mentioned them: building FCM, from research text, contextualizing the FCM model for offshore oil and gas, gaining insights through the model simulation and dealing with uncertainties, exploratory modeling analysis as a technique for simulation. And then I will summarize the result in a discussion and conclusion. And here I start with the foundation of my research. As I mentioned before, my work aims to model the practices of higher level organization and transfer them to the offshore oil and gas industry. HRO have enjoyed a record of high safety over a long period of time. And then as an example for higher level organization, 3 examples pertain for this: aircraft carrier, air traffic control operations, nuclear power plants. HRO research investigate the commonalities and practices of all of these different industries. Okay, so the higher level organization consists or include 5 principles. All of HRO share these 5 principles and they which characterize to the safety culture, namely preoccupation with failure, reluctance to simplify, sensitivity to operation, commitment to resilience, and deference to expertise. Each of these principles is identified through an extensive qualitative research that is clearly defined. For example, preoccupation with failure, defined as a chronic precaution that motivates a proactive and preventive examination of potential weaknesses and treats any failure or near miss as an indicator of potentially large-scale issues. Higher level organization theory recommends the companies strive to implement and consistently maintain all the 5 principles together. This results in organizational resilience, or what is mean to build a competence or capacity to cope with unexpected events when they occur, for example, emergencies or accidents. So, despite being a well-really researched and have a rich foundation in literature on HRO and widely accepted theory, research currently cannot fully answer several questions. First, it is unclear if all the 5 principles are equally important. The literature assumes they are equally important, but this has never been systematically explored. Maybe it would be possible for the offshore oil and gas industry to focus on only some aspect or some principles, not all of them. We currently do not really know if all the principles can be improved concurrently at the same time, as the literature assumes. It is possible that we get better in one principle, but we get worse or bad in other principles. For example, one of the principles is deference to expertise. It is conceivable that this trust in experts might cause people or lead people to be less vigilant and less sensitivity to operation, which is another principle of the HRO. To explore these type of questions, my research develops a system model from research literature. It can be used. Let me just move this. It can be used to try out happens under different conditions. In the context of system modeling, this trying out is called simulation. Higher level organization research identifies a series of actions such as a specific training and protocols that are intended to improve the HRO principle. However, because there is no HRO research on the offshore oil and gas industry, we do not really know if the same intervention also work in the oil and gas. One solution is to adapt the general system model that I developed here in this dissertation so that it reflects the specific industry context of the offshore oil and gas. In my work, I do this with the help of industry experts, and I call this process as contextualization. The result is a system model with 2 layers. At the core, can you see here in this graph, it's research defined, which is built based on academic research. And the outer layer is user defined, which means the industry expert practitioners interact with the model. Both of these layers, the core and the outer layer, are used in the simulation process. So, in a summary, my research, the objective of my research is to develop a novel mixed method approach to modeling the principle of higher laboratory organization as fuzzy cognitive map, FCM, based on published peer-reviewed literature. To achieve this objective, I am answering a total of 6 research questions illustrated on the right. The first 3 questions ask how to build a system model based on the literature. The 5th research question asks how the general model can be contextualized to the specific offshore oil and gas. And the 6th research question asks how I can use this model for decision making and pertain to how I want to use simulation. And lastly, the 4th research question is to how can I cope and deal with uncertainties resulted in the modeling structure. So now I am moving to explain how a model is actually built from research text. FCM, let me please explain the FCM, fuzzy cognitive map. FCM is a technique for representing systems as a network for concept and the causal connection between them. Concept can be freely defined and not necessarily to be quantitative. It could be qualitative concepts such as freedom, well-being, satisfaction, and any other qualitative concept. The figure on the left shows such a causal network. Concept A causes concept B to decrease and concept C to increase. The information contained in the graph can also be transferred to an adjacency matrix as on the right. An algorithm developed for artificial neural networks are used to compute how each concept in the FCM model change in response to activating single concept or combination of concepts. Let me show you how these concepts activating each other. If concept A is activated, it will transfer a signal to concept C and B based on their type of connections. And then concept C will signal concept B, and both of them will signal concept D. For example, if I could simulate how to increase in concept, how an increase in concept A change the activation level of other concept. If concept A were a safety intervention, for example, and concept D is an HRO principle, the simulation can tell me how D change in response to implementing A as an intervention. You can see here the outcome is a graph. In this situation, it's a bar graph that's showing me concept D is actually decreased. And also I gain insight how B and C are affected. In this case, they are positive. Now, I would like to explain that in my research, I build FCM model by analyzing literature on HRO through qualitative research process called thematic analysis and thematic analysis networking. In a sense, I go through the research text sentence by sentence, paragraph by paragraph to identify concepts underlying here in the piece of text on the right of the screen. They are underlined and highlighted in gray. In causal connections, you can see in the left graph or network, in this example, the word narrows and reduce indicate a negative causality or connection. They are in red. And breed indicate a positive causality, it's in blue. This analysis process is manual and require that the researcher deeply engage with the meaning and in the research text. Do not to forget that I used computer-aided program, which is the Atlas TI. So, however, to determine which research text I should include in the analysis, I used a systematic literature review and guidelines called PRISMA that resulted in 47 unique documents that were coded and just I have described. The results were a total. Here is the outcome of the coding process, and here is the final outcome, which is a total of 51 concepts and 138 causal connection between them. And here is the most important thing. In FCM, causal connection are weighted in the interval of between 0 to 1. 1 is interpreted as a very strong to maximum connection, whereas the value close to 0 is a very weak causal connection. Assigning these weights is important for being able to run simulations. However, the sample, as the example above show, research texts do not contain explicit information about the strength of the causal connection. For example, I know that success reduces or narrows perception, but I don't really know for how much, what is the weight, what is the strength between this and this causality. So The solution, some solutions suggest that in the literature to simulate the FCM as an n-weighted, which does not allow for fine grain analysis or attempt to assign weights through other sources independent from the analyzed text, such as surveys. Both did not work for my purpose. So I therefore developed a novel approach for weight assignment by adopting statistical measure that was introduced by Armborst in 2017 as a way to assess or evaluate the similarity between two related units of text. In my example, here in the graph, you can see N1 and N2 are two overlapping units of text in the same research article, which both talk about success and perceptions. Because I have coded the content through the lens of causality, I interpret thematic proximity to be indicative of the strains of the causal relationship between these two concepts. If success and perceptions are frequently mentioned in the document together, the relationship is stronger than if they were mentioned fewer or less. Importantly, the t-coefficient measure considers word frequency and overlap as opposed to other kind of similarity index and coefficients. As I just presented, I analyzed and coded 47 research texts, created network structure, and determined causal weight with t-coefficient. This ultimately resulted in an FCM model, as you can see in this graph, which is kind of confusing, but I will explain it a little bit. Above, it has 51 unique concept and 138 causal connection. As you can see, the 5 HRO principles are represented, for example, difference to expertise, here in the green, and commitment resilience in pink. Let me just take this and enlarge it so you can see better. And you can see that the contributing factor to each principle is pertained in these networks, and connection not only within just commitment to resilience, but it's also connected with concept and the difference to expertise. If one concept is actually activated or increased, this will separate out through the entire network. I not only developed a model, but rigorously tested it using strategies that I have adopted from the literature on system dynamics. Here is a flowchart of how I actually tested the model for verification. In total, I did 7 different model tests that fall into 2 categories. Structure test, which examine whether the relationship used in the model are appropriate representation of the real relationship with respect to the purpose of the study. And the other category is behavior test, which examine whether the model can demonstrate close enough behavior to the observed real behavior. As a summary one from what I've done so far, developed systematic process for creating and tested weighted FCM based on qualitative research text. This was possible through the novel use of thematic analysis and t-coefficient as a combination approach. And I created a general system model of HRO represented as an FCM that is dependent of any particular industry. Now, I will talk about model contextualization. The model I developed in general is applicable for any industry, regardless of their operational setting, but it does not reflect anything about the offshore oil and gas. Accordingly, I had to contextualize the model to the specific offshore oil and gas settings. Here in this graph, I will show you that this is the core model that consists of the 5 principles: sensitive to operation, reluctant to simplify, commitment to resilience, difference to expertise, and pre-occupation failures. These are abbreviation for the principle, and the core objective is the OR. And here's the outer layer where the participant from the industry will interact. Working condition and culture in oil rig is very different than in other environment. There is a concern that some of the things that work and improve HRO principle in some industries simply would not work for the industry of the offshore and gas. That's why contextualization is a main or core of my research. For example, HRO in medical field have good success with mindfulness as a practice to prepare people and keep them focused on the operation. But it may not really work for the offshore oil and gas. It could be rejected. It could cause problems. So to contextualize the model, I asked industrial practitioners to tell me how specific managerial intervention increase or decrease elements in the core model. In total, I collected about 13 distinctive intervention that's here appeared in the graph. And here's how the participant will interact with the model. So to contextualize the model, I needed data, and I collected data in two formats: a workshop and online survey. The workshop served as a pilot test to evaluate the general model and the purpose and the process for model contextualization and the purpose it was built for. It also provided an opportunity to obtain feedback from the participant because it was a workshop face-to-face. And then the online survey followed the format of the workshop, but it took it online to reach more people, and also allowed me to gain or to collect data in the form of agreement disagreement. That resulted in 40 usable responses. Here is, I'm showing an example of the how the model is contextualized, how the data is collected. The intervention in this example is safety huddle, which is basically, or more often used in hospital teams that gather people on shift and talk and prepare them for their shifts. And then I provided the participant with a concept from the model, HRO related practices called adherence to standard and risk boundaries. And here at the bottom of the survey, I asked the participant how they think about if there is an increase in the intervention of safety huddle with affecting adherence to standard and risk boundaries. They could freely choose there is no relationship, or they can choose there is a relationship if it's increasing or decreasing, and then actually weighted this relationship. As a summary to the overall process, an approach is really feasible. Industry practitioners understand the model really well and their output and relate them to their work. Contextualization by industry practitioners yielded unexpected but really plausible connections, relationships. Commonly described safety intervention may work differently in offshore and gas, and the contextualize can be done through online survey as well. Here, I am going to present how to gain insight through model simulation. The purpose of creating the FCM model is to gain ability to answer what if question is done through a model simulation. Here is the first model simulation result. But let me please first explain to you how a simulation of a model happened. It happened through 3 steps. First step, activate the concept relating to a specific safety intervention. Second step is to run the simulation. And the third step to observe how HRO principle change in response to safety intervention. In this figure on the right, you can see the result of implementing stop work authority. This means that any worker on oil rig have the ability or the authorization to stop work whenever he feels there is an unconditional, there is unsafe conditions. The model result, as you can see, an increase in preoccupation with failure, an increase in reluctance to simplify, an increase in sensitivity to operation, but decrease in both commitment to resilience and difference to expertise. If the company is very concerned about commitment to resilience because it's already there is a problem, it might choose to not use this intervention at all. Here is another example of the simulation, which is an intervention to strengthen or fostering social ties and mutual respect among employees. Yes, this actually impacted all the 5 principles together in terms of like positive degree of change, but this degree of change is you know, it's changing from a principle to another. They are not all equally the same. So as a summary 3 from what happened, this is actually telling me what about the intervention. That intervention impact high-level organization in different ways. Few intervention can improve the principle altogether at the same time or concurrently. Some have unintended consequences and reduce some HRO principle, diminishing return, which means that more effort would not lead to better improvement or outcomes. Recommendation in the literature is insufficient, is inefficient, and possibly even ineffective. Now, going through the dealing with uncertainty and high reliability is considered and is known to be complex topic, and people heavily really rely on experiences. As a result, it's quite common to be known that participants do not agree about one thing, and which in this research or this way of collecting data is connection or the edge weights between the concept and causal connections. The result is uncertainty about the model structure, which I had to use a technique called exploratory modeling and analysis that is referred to as EMA. In this graph, I would first define traditional simulation to make the difference between the both. Traditional simulation, or what is called non-to-be consolidated modeling, is simulating the model using one structure through using the weight of the relationship to be one value or crisp. Here happen in the section which is A, it's 0.66. So each causal, if I really tested different combination or scenario, as you can see here in this box, I would expecting I will get an outcome which is one value or 1 degree of change for each concept, as I used here 3 concept of interest. To compare this with the EMA simulation or explorative modeling, it is simulating the model considering the weight of the relationship between the intervention and each concept vary. There is a disagreement in the practitioner opinion. And here it's showing in the bottom part of the graph B. In this situation, in case of EMA, it's create a number of different model structures. In this example, 3 model structure. The model structure are pretty much the same, but the problem and the difference is in the weight, edge weight. Here, as you can see, the edge weight is a range between 0.33 and 0.99. And thus, when I do the same scenario, I will get 3 outcomes for each concept instead of 1. That is the main message of the EMA. Here is the first result from simulating the model based on intervention using EMA. I brought the traditional simulation next to the EMA outcome to make the comparison. You can see here at the right, which is the traditional simulation, which I just explained, stop work authority. The median here, it is exactly giving you the same outcome from the traditional simulation, and it's plotted on the EMA to show you the difference. So one practitioner can ask question, if there is a disagreement, would I really get a better result, better degree of change? In this case, yes. The EMA or the variation resulted in increase in difference to expertise, commitment to resilience, reluctance to simplify, and sensitivity to operation. And if I draw these boundaries, I would see, yeah, this is an enlargement, a better degree of change, better possibilities. But however, commitment to resilience is still negative. What does that mean? It means that the problem is not in the disagreement between the practitioner themselves, but it's in the heart of the intervention, design, and organization core practice. Here is another example, which is about the same. This is the outcome of the degree of change based on the mean, and here is the mean also plotted in the EMA simulation. And there is also a change here, but surprisingly, there is an increase in preoccupation with failure and difference to expertise, but unfortunately, a decrease in sensitivity to operation. Yes, the EMA gave me a better outcome for these 2 principles, but on the expense of this principle. This is the new boundaries of the expense. I took this, for example, because here is the thicker line, which means that the iteration that I've used here, which is 100,000, random number generated in the range. And this means that the thicker line, it picked the same or similar or very close edge weight many times. As a summary for EMA simulation shows how uncertainty about causal connection translate into uncertainty about outcomes. Practitioners can respond to the situation. They could accept the uncertainty and implement the intervention, but monitor the uncertain outcomes to be able to respond. and redesign the intervention so that possible and desired outcome can be solved. Invest in additional research to solve the uncertainty. However, many uncertainties do not really matter as much. And here, actually, I'm moving to the limitation, future research and contribution of my work. Like, and similar to any research, my research has limitation with regard to the actual model. Some of these limitations are inherent in the data sources I used. I reviewed 47 documents systematically selected based on predefined criteria. 13 specific industry intervention that is used in both HRO and offshore oil and gas, and the input from 40 industry practitioners. Naturally, additional data sources can really probably provide a better outcome. And luckily that my work develops a clear process for including additional sources in future research. Other limitations are inherent in the FCM modeling, which is basically the FCM does not provide an absolute value, but other than that, a degree of change. And there is a problem that FCM does not consider time lag. However, this is applicable for the intended application. There is also a limitation with regard to the model as a planning or decision tool. Currently, I am providing a proof of concept that is not used to support actual decision making. In the practice, this can be done as a future research as well. And as a conclusion, I have theoretical, methodological, practical contribution in my research. As a matter of theoretical contribution to the HRO theory showed through the model simulation that HRO principles are interdependent, but not fully complementary. That intervention that improves some principle make things worse for others. The decision maker need to carefully craft their strategies, protocol, synergies, intervention, and else. And as a matter of methodological contribution, I developed, implemented, and tested a structured method for building FCM model from research text, purely from research text. Approaches for assigning edge weight, which is the use of T coefficient, and for dealing with uncertainty EMA. And a practical contribution, contextualizing the model for the offshore oil and gas. So laying the foundation for a novel planning approach. And here finally, I would like to thank the audience for your attention and time, but please let me and give me the opportunity to loudly thank my committee chair and members. I particularly want to mention my advisor, Dr. Antonia Jedder, for her outstanding and exceptional support, and guidance during the journey as an advisor and very good friend to me, that she walked me through the journey from start to finish. I would like to thank my committee members, Dr. Wayne Wakeland, Dr. Charles Weber, Dr. Steven Skyfers for their amazing guidance and feedback and comments as they joined me in my journey starting with my comprehensive exam. I would like to thank all my family members. Particularly to mention my father, who passed away recently. Before he witnessing this, jointly with my precious and wonderful mother. I would like to say that this is the product of your unconditional love, continuous support, encouragement, and prayer. I would like to thank the ETM family represented in the chair, Dr. Anderson, and program director, Dr. Dime, and also the administrative staff and faculty member, as well as all my friends, PhD students. And let me here really thanks and loudly the National Academies of Science, Engineering, and Medicine for funding my studies, my PhD studies in 2 grants, collaborative modeling with fuzzy cognitive maps, a novel approach to achieving safety culture, which is started in 2016 and ended in 2019. And this grant that I'm currently working on, bringing higher laboratory safety culture, decision into focus, training with interactive fuzzy cognitive mapping. And also, which is started this year, 2020, and will be ended in 2023. And also, I would like to mention and thank Center for Offshore Safety for their support and assistantship during working with the workshop and also the survey. Thank you so much.
Thank you, Ahmed. Thank you very much also for your very kind words. And with this, I would like to open this for questions by the members of the committee. Who wants to go first?
I'd like to start by saying that, or asking about, you used extensively materials from the system dynamics literature, which I'm very familiar with and use for models that are based on differential equations. And you applied that, I think, I guess I'd like to ask you about what were the challenges and benefits of borrowing a testing strategy from one type of modeling and bringing it over to the fuzzy cognitive map area.
Yes, so in terms of system dynamics, as you build a model based on equation, I do not really have equation. I don't have units for the concept in the fuzzy cognitive map. It is challenging to use the system, to use the verification or validating test from the literature of system dynamics. However, there is another challenge is actually that I do not have an exact outcome from system to validate the model based on. So what I've used, actually the same literature, the literature was telling me stories about what if you do this to the system of the HRO, what is the outcome could be, which is basically also qualitative. So that is why FCM helped me, and it was a better and it's a really great choice to model the system of HRO based on. So the challenge lays again in two things. I don't have quantitative data and to compare with, and also qualitative data is kind of subjective. Would this answer the question?
That helps. I guess I'm curious. I mean, obviously, the two fields both attempt to give a picture of what can happen into the future, and so they are similar in that respect. But yes, you're right. I'm used to seeing, to having some sort of a, I guess you could call it a gold standard. I have real data, and I'm trying to replicate a pattern, a trajectory through time. And fuzzy cognitive maps are different, but they are trying to create a picture. It just seems like a challenge, and I think it's very resourceful and creative for you to have found a body of literature that, and then figured out how to adapt it as best you could.
Yes, some actually from the literature, some from the experience as well. For example, if I want to test something called anomalous behavior test, I do not have exact data to validate the model based on, but I have behavior that happened before in the specific offshore oil and gas industry or specific healthcare, that when they, for example, did something, foster social ties, what is going to happen to the system and how this really affecting the behavior of the model, the behavior of the concept of interest, which means in this situation, the 5 HR principle. It actually behaved like what they were describing. This is how I validate my model based on, or verified my model. It's not actually validated.
All right, thank you.
No problem, Professor. Yes.
I got a whole bunch of questions, which I won't get to all of them, so I'm going to try to focus on the ones that I think are most important. So we've discussed before how you gathered data, and you mentioned a workshop, and I'd like you to give some of the details on how you proceeded at that workshop and how you were able, your interviewing strategy, and anyway, how you're able to gather that data for the qualitative part.
Yes. Yes, so the workshop is actually held by the assistantship of Center for Offshore Safety. It was a funded project by, as I mentioned, by national academies, and the project, the workshop held in Houston, Texas at the headquarters of Center for Offshore Safety. So they were able to bring us some participants from the industry, different safety rules, safety managers, safety auditors, specialists, and others, and even operators from leading companies, ExxonMobil, Chevron, British Petroleum, and others. About 22 participants attend the workshop. So what we've done, we actually presented the work for them to understand what is this research all about. And then the team, or 22 participants, they were grouped into 3 teams. These 3 teams, each one given a handout with a definition of an intervention and a list of corresponding high reliability organization concept, which is basically the model concept. And I also asked them the same question: do you see any relationship between the model based on the definition, between the intervention based on its definition, and the model concept based on its definition? And we asked them to weight that. So the team, each team, they were agreed about one weight, which is a crisp value, which means that the traditional simulation applied at that situation. That was happened in the workshop. This is how we collected the data. I plugged the data they gave me into Mental Modeler software, and then generating an adjacency matrix, and then used them into a Python package for simulation, simulated the model based on their own input, and then presented these data to them. They can see what their decision making really happened. The good thing about that, the model appeared to be really feasible, and I did not have any problem on the model structure. In fact, it showed me that things as a researcher I wasn't expected, but it is actually appeared in the literature on offshore oil and gas and also HRO, which is really gave me more confidence about the model.
Okay, thank you.
No problem, Professor.
And I should probably shout out to Dr. Cyphers, and actually I see Dr. Aminpour in the audience, who were actually helping or also part of that workshop. So they know this data super well, and I'm happy that you're here today.
And also I want to mention that the Python package that I used to simulate the model, it's a product of Dr. Payam Aminpour.
Any other questions, Stephen? I have a bunch. I still have questions, even though I know the work quite well, but I wanted to give Dr. Cyphers an opportunity to ask questions.
Sure, yes. So mine is a bit more conceptual, but it was related to the individuals that were participating in the workshop. And so, you know, I thought you did a really great job with the presentation and describing how those models came together. One thing that I've been curious about is you had so many different organizations represented, like you mentioned, and in the real world, those organizations are kind of competitors. They're not necessarily incentivized to work together. But this model is somewhat of a representation of them bringing their knowledge together. And I wondered if what you thought about the potential for misinformation contributing to a model in a case like that, or if there's a way that you can test for, you know, misleading information as you put something together.
You mean missing concept in the model?
Or perhaps it might be within the uncertainty analyses that they're looking at, but if some of the surprising outcomes might be from the fact that they might not be incentivized to share everything with their competitors in that type of scenario, or is safety something that's unifying? Is safety something that they're all willing to contribute to?
Honestly, Professor, I was really happy that they were from different organizations, with different settings. The reason why is that I wanted to get the more expanding range of uncertainty or disagreement. I wanted to know what if they actually disagree from -1 to 1, which is exactly the entire range, to see if I use this kind of uncertainty, how my model would behave. The most important thing here is to create an artifact that can be used by an organization A and B later. So now I want them to disagree. I want them to have a contradiction spirit, because then I want to verify and gain more confidence about the model, and then organization A can use it exactly as what they want. And then they decide the range of the disagreement and intervention. Does that answer the question?
Yeah, that was great. Thank you.
Thank you.
I have a question. So you know that one of the things I'm most excited about is your very innovative use of T-coefficient, which itself is a new thing. This is a 2017 paper, and you set out and said, well, this is a cool thing that I can use to assess the causal weight in an FCM, to quantify the causal weight based on qualitative tests. How do you know that works? I mean, how do you know that what you assigned, a 0.66, is really a meaningful weight? What did you do to gain confidence that this is a good method?
Okay, so there are actually other techniques for calculating thematic proximity. One of them known to be Jacquard similarity index, and the other one is known to be cosine similarity index. They are really different. The first one is considering co-occurrence and occurrence with not any intention to consider the overlapping and the content that they are sharing, each causal related concept, and the other one is considered or called as a bag of words. So the first one has a really limitation, limitation found, and to use this method in a software to collect and retrieve information. The other one has a limitation that when you, for example, missed a document or a piece that is not giving you any insight other than just duplicating the content, it will give you a weight that is really highly larger than the normal. So I was looking for something to tell me two things. First, the T coefficient is coming from my engagement with the data, because I used qualitative method thematic analysis that need an engagement with the data. It doesn't matter how they occur or don't occur. It doesn't matter actually what is the content, if it's duplicated or not. What it really matters, when two concepts are mentioned together frequently, that means they are more strong. Or when they are mentioned less frequently, they are less strong. This is giving me more confidence about the use of T coefficient. And then actually what I did, I calculated all the edge weights of the model using Jacquard similarity index and cosine similarity index as well. And then what I did, the calculating of all the connection, 138 causal connection in the model, I categorized them into 3 categories: weak, moderate, and strong. And then I calculate the compatibility. First of all,
I'm sure you have a slide on that. That would probably be easier for the audience to appreciate.
Can I go to the slide?
Yeah, sure. Use whatever slide you want to use.
Let me show you this. So here is the actually the 2 coefficient I use, Jacquard similarity index and cosine similarity index, as I mentioned. And when I categorize the weight into 3 categories to be able to plot them all together on the same plot. First of all, let me take this section to show you. It's showing you that there is a compatibility, not 100%, it's 80% between C coefficient and T coefficient, and 73 between cosine index and T coefficient. But you can see that there is a similar pattern in the way that they increase and decrease. Also, if you can see here, the Jacquard similarity index is giving you a really low weight that's beyond or not can be considered as a kind of connection, although I can actually convert them all into percentile, but however, it will still technically, it's not showing a reality as the T coefficient, which is between 0 and 1. This is what I was looking for. And this is how I gained confidence about the use of T coefficient. And also when I tested the model for verification and used the model in the pilot study, all these kind of tests gave me confidence that this is really what I wanted to know. This is really what I wanted to see in the model behavior.
Okay.
Does that answer the question?
Yeah, thank you.
No problem.
I have a different kind of question. If I could ask you to go to slide number 38, where you summarize your contributions, I would appreciate it if you could look at these contributions and tell us kind of how they are going to lead to publications. How are you going to get the word out about your contributions?
Yes. So the first contribution, which is the theoretical contribution, first of all, I have a publication under now in the final stage that's going to show how the FCM developed based on HRO literature. This is one thing. This is how I moved the literature on higher level organization theory into practice, actually from qualitative into more quantitative. And also this is showing the other innovation, which is the methodological innovation, the use of T coefficient. This paper is going to actually showing both theoretical and methodological contribution. As a matter of practical contribution, my model that I built and tested and used, it's going to be used in another study, which is recently is ongoing, as also a part of a grant funded by national academies. And other things, I have also another publication which is literature review, which I'm as based on your recommendation, it's not going to be as a matter of literature review, but it's the state of the art of higher level organization theory and how to move them from shelves. 30 years of literature, great, awesome literature, need to be actually used. So that's why I'm planning for that as well.
And what journals or venues are you looking at?
So the theoretical contribution of building the FCM and USDT coefficient is going to be on soft computing. And
that's but that to me is a methodological contribution, right?
Yeah.
So where do you plan to take, because that's an excellent, where do you plan to take the new insights on high reliability theory, which is, well, the recommendation that you should just improve all 5 principles all the time is not working quite so well. So that's important for organizational researchers, but where would you want to position that?
Can you say the question in a different way, if possible?
So one of your theoretical contributions is that those 5 principles of high reliability organizations are not complementary. You cannot improve all of them to the maximum all the time, but there are interdependencies between them.
Yes.
And the literature currently implies, well, just get better at all 5 and you will be fine. And you say, well, this is not how this works. So this is important. Where do you inform people about this theoretical insight into how safety culture works? What's the outlet for that?
The first thing, actually, I think the most important thing is to train people. Train them on how to become high reliable, how they become resilient. And by that, I would guarantee not guarantee, but I would hope really as the outcome of the simulation that training is the real intervention that's going to give you the package. First of all, whenever you influence any of the principle, the other 4 principles will be influenced as well positively. So training is, I think this is the best thing that we could do in order to have them complementary, have them all together.
Is there a place that you could publish or where you could talk about the training opportunities so that the right people would learn about them and contact you?
Yes. This is actually, as I said, it's an ongoing research to turn this model into a training simulation tool that help people, train them online and how to be more reliable and how to attempt to achieve the package, which is basically the 5 principles altogether concurrently. Because currently, right now, not everything is going to lead me to have the package.
I guess we're all trying to poke you in a certain direction, or I am at least, and that is, what do the executives and decision makers in the industry read where you can put something so they find out about your work?
Yes.
What do they read? Are there journals that specialize in the practitioner side of HRO?
I would say that there's, of course, there's still HRO still under research and under intensive research in many journals, safety research journals, safety science as well. And there is actually industrial psychology, industrial safety as well. These are all matter of very high level journals that I would really dedicate, I would say, the rest of my life to really move this into better and more, and probably I have something in my mind right now. For example, in the model that I built, I have some external and internal concept, and some of them are excluded. As I mentioned before, I need actually to see and study if these excluded concepts can be actually contribute into the theory itself, like a 6th principle, for example. How would the model would behave? How would the system would behave? Would really affect making organization better or not? So I really want to explore all of these things, starting probably from tomorrow.
Yeah, I think Dr. Wakeling was trying to invite you to also think more in terms of practitioners and their outlets. And I think you have a great start with the relationship with this safety, where practitioners meet to learn about safety. And I think also Lillian Espinoza is in the room as a guest. And so she's also helping to spread the word in the industry. Yeah, I'm sure there are other questions.
Yeah, so if there is time, so I can ask a question. If there is
Yeah,
not, so that's fine.
I am absolutely. There will be time. I just want to give all committee members the opportunity to still chime in if they have something first. Charles said he has a long list of questions.
Yeah, I'm not going to go
ask
through all
one.
of them, but there, I have a suggestion in the context of the last question. There is the Informs Journal Organization Science for your theoretical contributions. Now, they may consider this a bit out of bounds because it's unusual for what they usually do, but they might be open-minded enough not to desk reject it. And I think this could take that community into a new direction. So that's just a suggestion.
Thank you so much.
Okay. Could you please go back to slide 33? I'm going to ask you about radar charts. Okay. Okay, so all of these, okay, we know that radar charts are actually not circles. They're multi-dimensional. They're multi-dimensional entities. So these vectors could be orthogonal, right?
Yeah.
So when you display them like this, how much it sort of distorts how much the improvement or reduction in capabilities actually is. Can you give me an insight into how much how much the actual improvement is beyond?
Well, FCM in general does not give you an absolute value. It gives you a degree of change. So
Yeah.
let me give you one example. This is the median line.
Yeah.
If you can see here, this circle telling you the degree is negative 0.75, and it's actually moved into almost 1. So this is all the range of increase. But here, if you can see, the change or the increase from probably it's in the middle between -1 and minus 0.75 into minus 0.5 as a maximum. So it's still in the negative range. It did not actually change anything. Here, the change is like an interval. It's still not an exact or absolute value.
Okay, so but what I'm saying is, is there synergy between these, right? I mean, if you display them on the circle, you come to one conclusion. But if you want the overall contribution, you would have some hypervolume or something. So you have some sort of assessment of what the integrated contribution of this method is.
Yes, but actually there is no synergy. When they increase based on the range of uncertainty. It's not necessarily the same. As you can see, this one is different from this one and from this one.
Okay, all right.
But
Okay,
was that your question, Charles? Or or was your question, is there a synergy between those 5 principles?
No, the question is the integrated contribution. I'm thinking in 5 dimensions here. He's got 5 dimensions. So here it shows some essentially this hyper rectangle or this tent or whatever it is not quantitatively or does not quantitatively reflect the actual improvement. So I wanted some assessment of what the difference actually is if you go on all dimensions.
And do you know, Professor, I would add something that cultural behavior in general, you cannot actually say that I improved the culture of my organization into level of 0.75. You can see the cultural improvement in terms of their outcomes, in terms of their behavior and attitudes. So that's why FCM is really great method, because it gives you a degree of change, not an absolute value, because I'm basically modeling cultural characteristics.
Okay, well, I guess that sort of answers it. It was a bit out of a question that might have been not exactly to your topic. So anyway, so thanks, that's okay.
No problem.
There aren't any pressing questions from the committee. I'd like to open it to the general public. And Dr. Aminpour, you had a question.
I'd like to make a comment.
Oh, yeah.
I know a lot of the people that attended that workshop.
Vivian, can you go very close to your microphone? Yes. You're difficult to understand right now.
Is this better?
Yeah.
I know several of the people that attended the Center for Officer Safety workshop. In fact, when I started working with Antoine recently, I asked Charlie Williams, and he said everybody was so excited that Ahmed came and even asked the question. You know, and no one actually seemed to ask these questions before. Now, one of the things I'd like to say is the people that attended that workshop were invited by Center for Offshore Safety. So you didn't get input from the people on the sharp end of the spear, the actual people working on the rig. In the future, might you try to do that? Stop work at 40?
Ahmed, I think that's an excellent comment. So you did not talk to oil rig workers. Is that the next step, or did you have reasons to not do that?
What was the question, Professor? I did not.
So you did not involve actual workers on the rig. You talked to safety engineers and safety
Yes,
managers.
that's right. That's right.
Is that deliberate for good reasons, or is this just because you get to the other guys later?
Because I got to the other guys later and was not easy to reach them, to be honest. Yeah.
And I would also claim that I mean, to some extent, you probably also want to build managerial flight simulators for the people who make the managerial decisions.
Yes, exactly, because those people are making the decision making. Yeah. Process.
But so that's definitely in future research then.
Yes.
Ahmed, one just quick clarifying on that. Could you describe again your sample for the online survey though? Because I remember your online survey had a more diverse like response group than the in-person workshops did. Because you sent this out across LinkedIn and a few different modes.
Yeah.
Yes.
So who were the people in the online survey? What do you know about them?
Yeah, the people on the online survey, I was able to first meet them in person in the annual forums of the Center for Offshore Safety. I was able to meet them, talk to them, got their business cards, and some of them, they were willing to participate. And I was really careful about who is going to be a participant in this survey. And then other channel for recruiting participants were the Center for Offshore Safety themselves. They provided me with a list of particular potential participant. And then the other thing that's actually really was also, I forgot to mention, Dr. Wesley Williams from Louisiana State University, he helped me to get the survey link and definition and explanation on LinkedIn account that he has many people specialized in the offshore oil and gas. So that's how the survey was distributed.
Yeah, but that sounds you were still skewing heavily towards people in managing and planning positions.
That's correct. That's right. Yeah, that's right. Only actually one based on the comments that provided to me from people through the survey. The guy or the guy, I'm not really sure, it's just anonymous, but the outcome that I received, it sounds to me that this person was really on the rig, because what he was recommending me, especially about stop work authority, he was mentioning things in his comment that it's actually confirmed that he or she from the rig.
Yeah. Okay. So back to Dr. Aminpour, you had a question.
So I actually have a couple of questions. First of all, I really enjoyed your presentation. That was amazing. That was an amazing work.
Thank you.
I'm really happy for you.
You were a part of this, of course. You know that.
You did the job, I think. So,
yeah, I mean, yeah.
Yeah. So let's go back to the question. So you have a list of interventions. So I want to know where this list is coming from. Is it coming from the literature, or is it open to the public or open to the experts and they offer their interventions? So that's the first question. And so the second question is about the uncertainty analysis. When you are doing the uncertainty analysis, you have interventions introduced to the system, and you have survey respondents giving you weights, different weights, how this intervention is connecting to other concepts in the map. So you have a range for each connection, right? So,
yes.
So how did you sample from this range? I mean,
Great
what
question.
kind of probability distribution did you use, and whether you run a Monte Carlo simulation in which you change the weight of the connections on all of them, or just short list of all, connections that you have.
Okay, so the first question was about how did I get the interventions? The interventions are all, not all, I would say 90% of them from the literature on both high reliability organization and offshore oil and gas. I was reading articles and material from the literature that were mentioning people did this and these are the outcomes. So these intervention, their definition, their use is split. I got them from both literature, HRO and offshore oil and gas. This is the first question. The second question, let me show you something, which is basically the uncertainty range. If I, yes, here. This is the outcome from the survey, okay? Here is one of the intervention called practicing individual mindfulness. And this is the relationship with one of the concept here, model concept. So in this particular case, 6 people took this survey. And then of course there is these statistics, which is the standard deviation, the mean, and the maximum and minimum, as you can see. This is actually the exploratory range. Because I did not have so many input for each connection, I did not run probability distribution. So I was able just to get, first of all, calculating the median to do traditional simulation, and then actually taking this range minus 0.6721 as an explorative range. This is one thing from your question. The other thing of your question, which is, did I really do all the exploratory modeling? Was that your question?
Yeah. So did you play with the with the edge weights of all interventions?
No.
Or only
No.
you run a scenario, you play with the weight, and
No.
you do that just for that specific intervention, right?
I will show you something. For each intervention, this is an example. This is the intervention. These are the list of corresponding concept that's potentially could be affected by the intervention. So for each intervention, I had to activate it for a causal relationship with one concept to see if the 5 principles present any sensitivity. If it's present sensitivity, which is in this case, there are 6 concepts as a potential list for this intervention, only 2 of them show sensitivity to the change or variation in the edge weight between the intervention and the concept. For example, here, institutionalized pro-social motivation, the outcome of the connection with the self-awareness actually resulted in all principles to be sensitive, and the range of uncertainty is between 0 and 0.67. I did run simulation as an EMA simulation only for the connection that is, or the intervention that is gave me uncertainty range. And because of that, I ran traditional simulation 13 times because I had a 13 intervention. And for the EMA, I ran only 6 because I have only 6 intervention that led to their variation in the edge weight with the corresponding list to uncertainty in the HRO principle, the 5 HRO principle. Did that answer the questions?
Yeah. Yes.
Okay.
Thank you.
Thank you. Hello?
Sorry, I was muted.
Oh,
Typical
okay.
typical Zoom thing.
Okay.
So we have about 4 or 5 more minutes for questions from the audience. So I'm wondering if there are additional questions or comments. And Melissa, I think you are monitoring the chat. If people want to put questions in the chat window, that's possible too.
I am monitoring the chat, yes. However, I have seen nobody post in it yet.
Okay. Okay, any additional questions, comments?
So Ahmed, very nice job. Congratulations on a well done presentation. What do you plan on doing next? What are your career plans, and in terms of making use of this work?
A great question, Professor. Thank you so much for attending this presentation and for treating me as a PhD student in the department since 2015. So, however, the next step is I have an opportunity to work as a postdoc in a funded grant that is ongoing right now. So this is a year, but I am going to search for a job. Basically, I would like to stay in academia. That is my goal, is to search an opportunity to be in academic field, to be a professor in one of the schools. But that's not opposing any opportunity that I may gain through the searching process to work for industry as a consultant as well. Professor Yeder, I have in the chat.
Okay, perfect.
No, this is not a question. This is Pam.
Okay.
Thank you, Pam.
Okay, then if there aren't any additional questions from either the committee or the general audience, then Melissa will take the committee into a breakout room for committee deliberations, and everybody else can stay on this call and hang out with Ahmed while he's waiting for feedback and results. Okay, so see you in a bit.
See you, Professor.
And Ahmed, I'm not sure if you would like people to post in chat and chat with you that way. You can always read the chat and respond to it, or you can invite people to unmute themselves and make comments if they're interested.
Okay, that's great. I can see that. But Melissa, I have a question, if that's possible. Can I get 1 minute just?
Can you get 1 minute what?
Just a rest and we'll back. Is that possible?
If you would like to turn your video off, we can take a minute break for you.
Okay.
You can come back and turn your video on when you're ready.
Thank you so much.
Ahmed, can you hear me?
Yes, Liliana, we can hear you.
Okay.
But Ahmed will need to unmute himself now that he's back.
Yes.
I was very, very impressed by that.
Thank you so much.
You know, the Center for Officer Safety was formed, but, you know, Congress, the presidential report demanded that we create a Center for Officer Safety because of my conduct. And also because in that accident, people knew things were wrong, but they did not know how to use stop work authority or how to raise an issue.
Mm-hmm.
And so this is why I think your research is just so critical for the future of the offshore oil and gas industry.
Oh, okay. Oh, yeah. Yeah, this is expected. Yeah. Hopefully I will be a part of the offshore oil and gas industry soon, so I can contribute to their safety as possible as I could. I'm just hopeful.
Well, I hope so too.
Thank you.
I'll also give you a list of publications, that are in this, I'm on the human factors,
Yes.
national committee. So there's a whole bunch of journals and researchers that are dedicated to this HRO.
Yeah. Actually, as we are going to move on the postdoc position in this grant, I'm expecting we will make several contributions, several publications. This is a must.
Yeah. And also, hopefully you'll be able to present this work, directly to industry.
Yeah, hopefully.
No, I think you will. Last year we had 11 fatalities in 2019, and the number of injuries and explosions and fires, it was just really tremendous. We've already had 3 people die just in the last 4 months.
Oh, wow. Sorry to hear that.
And that doesn't even count the number of injuries. But, the mindfulness part, it's really difficult to be mindful when you're in the midst of the COVID-19 and also having to evacuate all these hurricanes. Like right now, all those people are just evacuated from Laura or Sally, and now they're evacuated again. And then to go back and turn everything back on, this is when it's so easy to get distracted.
Yeah.
The man killed on August 23rd. It was a deep water drilling rig, Pacific Drilling, and he was crushed to death. They were pulling the riser to evacuate from the storm.
Mhm.
So it only takes like 1 second of distraction to take a life.
Yeah.
So I just think your research is really critical to the future of our industry.
Actually, this research is triggered my background as I was working in operations. Yes, it is not offshore oil and gas, but it's still also kind of complicated operations, cement manufacturing. And yeah, the problem, we had a really bad culture. I'm talking when I was on home country. We had a bad culture, and the committee back. Okay.
And Ahmed, while they're coming back, we did have a few people post in chat. So if you'd
Oh,
like
okay.
a few minutes to read that,
Yes. Yes.
perhaps the committee would have time for that.
Okay.
So are there more questions in the chat, or?
No, just congratulating.
Oh, okay.
Just messages.
So I think the committee is all back, and we would like to take the opportunity to congratulate you for a job very, very well done. So congratulations, Dr.
Congratulations.
Thank you so much.
Very
Thank you.
well done.
Yeah.
Thank you, Professor. I appreciated that.
And I'm so glad you made the choice to open it up to the public. I know you didn't have to, but I'm glad you did. I think it worked well.
Thank you, Dr. Wayne. Thank you so much.